All right, so we've talked about graphing exponential functions. We've talked about writing them using graphs. We've talked about writing them using story problems. We've interpreted them, what they mean, and how they apply to real-world situations. But we haven't really talked about what happens if you're given a table that looks like this, and you have to find the equation for it. Okay, so I would like to show you in the calculator how we can use the calculator itself to actually find the equation for these lines, or for these points, I should say. All right, so first thing, you're going to go to Stat, and then you're going to go to Edit. Okay, so number 1, it should already be highlighted. Hit the Enter button. L1, we're going to put all of our X values. L2, we're going to put our Y values. Okay, so we go 1, Enter 2, 3, 4, 5, like that. And then for L2, we're going to go 4, 10, 25, 62.5, 156.25. There we go. All right, so once we have the points that we're given put into our calculator, we're going to go back and hit Stat all over again. Okay, and instead of using what's in the Edit column, we're going to go over to Calculate. All right, so in that Calculate list, you're going to see a couple of things that we've used before. So we've actually already used a linear regression. Remember, we let the calculator make the lines for us or come up with the equations of the lines for us. And we're going to let the calculator do the same thing with an exponential regression. So that's going to be EXP, all right, for exponential. So we're going to go ahead and hit Enter. We're going to hit Enter till we get all the way down to Calculate, and we're done. So these points right here, down here on the sticky note, sorry, it's dark, so our initial amount is 1.6. So that right there is where my y-intercept is. And we're growing at a rate of 2.5 every time. So if I took 4 and multiplied it by 2.5, I'd get 10. 10 times 2.5 is 25. 25 times 2.5 is 62.5. Does that make sense? So our equation is just A, so 1.6 times 2.5 to the x power. All right, and so we're going to do the same thing. I'm going to show you a second example. Okay, so we're going to go back to Stat, Edit. Excuse those numbers. Those numbers for some reason didn't work. So we're going to use these ones right here. Looking at this table, the first thing you should notice is that as the x values go up, the y values go down. If my y values are going down, it's an exponential regression. Okay, so I know, or not regression, it's a decay, I'm sorry. So my graph is going to go down. Okay, so we're going to go to Stat, Edit, and my x values are the same, so I'm not even going to play with that column right there. I'm going to look at L2. You can actually type your y numbers in on top of that, or you can actually clear them out. So if you go up to L2 and hit Clear, and then hit Enter, notice that like my entire column just cleared itself. Okay, so I'm going to go ahead and type in my y values. So 81, 27, 9, 3, and 1. Okay, so once I get everything plugged in, I'm going to go back to Stat, Calc, scroll all the way down to exponential regression, that's 0. Okay, so if I hit Enter, go all the way down to Calculate. So A, that's my y-intercept, okay, so that's my initial value, that's where I'm starting at. And B, it's 0.333333333. Sorry guys, definitely interrupted. I don't remember where I was, but I remember that I hit Enter, so it tells me what my initial value is. So I have my y-intercept, and B is 0.33333, which means we're going down because that is a decimal. It's less than 1, so we know it's a decay. And remember, 0.33333 is the same thing as 1/3. Okay, same thing as 1/3. So my equation would be 243 parentheses 1/3 parentheses to the x exponent. Okay, let me know if you have any questions.